Hi guys, today I'm coming to you with a video about binomial distribution. In this video, you'll be able to identify what a binomial probability looks like. You'll be able to solve it, and throughout the tutorial, I'll be giving out some calculator help. So let's get started. 15% of adults say they can't cook. Suppose we took an SRS of 20 adults. Let's prove that this is a binomial distribution. Okay, so there are four things that are required in order to prove that something's binomial. And the four requirements we call bins. B means binary. And in this case, binary means they can cook or not cook. I means independent. And independent means that because one person can cook, that's not going to change the ability of the next person to cook. So in this case, it's definitely independent. N means a fixed number of trials. In this case, that's 20 adults. And lastly, S means the probability of success is the same each time. And in this case, we said that the probability of success is 15%. So because it followed all four requirements, this is definitely a binomial distribution. So let's go ahead and get started and try some problems. Assuming I can turn the page, hold on. Okay, 15% of adults say they can't cook. Suppose we took an SRS of 20 adults. What's the probability exactly for can't cook? All right, so I'm going to show you how to write it, and then I'll show you how to use your calculator. So we always start by defining X. So X is going to be the number of adults who can't cook. And in this case, we're looking for the number of adults who can't cook is exactly 4. So, the formula for binomial distribution, for binomial probability, is P of X equals K equals N choose K, P to the K, 1 minus P to the N minus K. This is in your AP booklet. You do not have to memorize it. All right, let's go through this slow. N is the sample size, and we said that earlier that our sample was 20 adults. We want to choose 4 that can't cook. The probability an adult cannot cook is 0.15 to the success power. So this is how many we don't want to cook. And the probability they can cook is 85 to the N minus K, 16. All right? Or if you like writing it the calculator way, you would write binomial PDF. Remember, P means point. N is 20. P is 0.15. And K is 4. All right? So we can use our calculator to make that go a little faster. So I'm going to do probably this one on my calculator. So I'm going to go to second vars, and binomials here at the bottom, PDF. And I have 20 trials. The P is 0.15, and the K is 4. So the answer is 0.1821. So there's an 18% chance that in a group of 20 people, 4 will say they cannot cook. All right, let's try another one. Okay, 15% of adults can't cook, same problem. What is the probability that more than 8 can't cook? All right, we don't like writing it like this. We like to write it as an inclusive inequality because it just makes it easier for the calculator. So the probability that X is greater than 8. Numbers that are greater than 8 are 9, 10, 11, 12. So we started with the number 9. So the opposite of this is 1 minus the probability of less than or equal to 8. And the reason we're doing the opposite is because our calculator, if you want to use it, can only do less than problems. So this means that you're trying to solve for x equals 8, 7, 6, 5, 4, 3, 2, 1. Now you could do that if you want, but your calculator can do it all at once for you using the binomial CDF. And you're going to use the same order as before. N is 20, P is 0.15, and K, because it's a CDF, you tell the calculator where to start that boundary. It'll start it at that number and work all the way down to 0. Okay, so using our calculator, binomial CDF, so we're going to go to second vars, binomial CDF, N, P, K, and we get 9987. 1 minus that, and that's 0.0013. So what that means is that in a group of 20 adults, the probability that you'll find more than 8 that cannot cook is 0.001. It's pretty low. It's not likely to happen. Okay? All right, and last one. How many do you expect to say they can't cook? What's the standard deviation? And interpret. So again, we're still dealing with a binomial probability or binomial setting. The formula for binomial mean is n times p. That is in your booklet and you do not need to memorize it. Okay, n is the sample size, 20 adults. P is the probability of success, that's 0.15. 20 times 0.15 is 3. So you're saying that in a group of 20 people, 3 will say they can't cook. Standard deviation is the square root of n times p times 1 minus p. So that in this case, it's going to be 20 times 0.15 times 0.85, which comes out to 2.55, which comes out to 1.59. So here's the mean, here's the standard deviation, we're ready to interpret. So in a sample of 20, and that's important because if my sample size is different, the mean is going to be different and the standard deviation is different. So in your interpretation, you have to say how big your sample was. So in a sample of 20, I expect, on average, 3 people to say they can't cook, and that number can vary by 1.59 people. Okay, so that's how you find mean, standard deviation, and how to write a sentence. So hopefully this video helped clear up any questions that you may have. Good luck studying.